Let's work through a past exam problem that's all about indifference curves and utility functions. So as always, I'm going to talk through how I'm parsing the language of the problem and then how I'm going about figuring out the solution. All right, so let's take a look. So for all the scenarios below, draw a set of 3 indifference curves. So that's the first thing I'm looking to do, and write down a utility function. So that's the second thing that I'm being asked to do, consistent with the description of preferences. Clearly label the axes for your graph and make so that the utility function contains only the variables in the problem and numerical constants, no alphas or betas. All right, so I need to have numbers in there for every function. Let's get started with part A then. All right, part A. Bradford likes both action movies and comedies, so A and C are my 2 goods here. So let's go ahead and get started with that. Utility is going to be a function of A and C. Right? Watching 2 more action movies always gives Bradford the same additional utility as watching 1 more comedy. All right, so action movies are increasing utility, comedies are increasing utility, and if 2 action movies give the same additional utility as 1 comedy, it sounds like we don't have any diminishing or increasing utility. We've got constant margin utility. So I'm thinking about a linear utility function then, right? But now I need some coefficients out in front of here. So if 2 action movies give the same utility as 1 comedy, well then a comedy is worth twice as much as an action movie, right? And so I'm going to put a 2 there in front of the comedy. Okay, and so 2 action movies, each action movie is going to increase my utility by 1 unit. So 2 of them increase the utility by 2. 1 comedy is going to increase utility by 2. So that checks out. All right, let's move on to part B here. Colleen dislikes comedies, but loves action movies. All right, so C is bad, right? A is good. So I just want to keep track of that here. While she likes action movies, each additional one she watches increases utility by less than the previous one did. Okay, so that tells me that margin utility of A is going down as A goes up. Right, so I'm just translating the language of the problem into our standard notation here. Each additional comedy movie she watches has a smaller impact on utility than the previous comedy did. So also diminishing margin utility, but I'm going to write that with an absolute value in there because remember, C is bad. So that margin utility is actually a negative number. Okay. All right, and that is as C goes up. All right, so let's think about our utility function now of action movies and comedies. So I need C to be bad, A to be good. So I'm going to put them in separate terms, and that way I can put a minus sign in front of C. That makes it bad, right? So positive sign in front of A, good, minus sign in front of C, bad. I'm going to use exponents to get this diminishing margin utility for both of them, and it's going to be a fractional exponent that's going to do that for me. So it doesn't really matter what I pick as long as it's bigger than 0, less than 1. Let's keep our lives simple and make them both 1/2. Right? And so there we go. Moving on to part C now. Desmond always likes to watch action movies and comedies back to back. He only gets enjoyment from watching 1 more of each. If he watches an extra action movie without watching an extra comedy, he doesn't get any additional utility from the movie. If he watches an extra comedy movie without watching an extra action movie, he doesn't get any additional utility. All right, so Desmond here seems to be combining these movies in a 1-to-1 ratio, and they have to be combined that way for him to get utility. So these are our perfect complements. All right, so we realize we're in this special case of perfect complements. And so when I write down my utility function, right, I'm going to be constrained by whichever type of movie I don't have enough of, right? So if I only have 5 comedies and I have 10 action movies, well, when I'm watching them 1-to-1, I can only watch 5 pairs of movies, right? So I'm constrained by the minimum of the 2 types of movies, right? So that's just our classic perfect complements utility function there. All right. Okay, so we've got our utility functions. Now let's switch over to doing our indifference curves part. Kind of went utility functions first just because I found it easier to write down that information as I went. And now I'm going to step back and do the indifference curves because I find it easier to do those once I'm looking at my utility functions. You might find it easier to do it in the other direction. Okay? All right, so now that I've got my utility functions, we don't need to look up at the problem anymore because I'm pretty confident in my answers there. So let's start with part A here. So I'm going to go ahead and stick with action movies on the horizontal axis in each one of these cases, right? And comedies on the vertical axis. All right, so my first utility function, it's going to be these straight lines. That's what we get whenever we have the perfect substitutes, that linear utility function, right? I'm not going to worry about getting my slopes to look like the right numerical value slope. I'm just going to write the right numerical value, right? I'm not going to waste time during the exam trying to make it look perfect. It should just look like a straight line. Now, what's the right slope here? Right? We go back up here and we realize that the margin utility, well, let's just write it out. Should be margin utility of A over margin utility of C, right? Well, that's just minus 1 over 2. Right? Which makes sense. Since we like comedies more, if I give up one comedy, I have to give you 2 action movies to make up for it. Right? Okay. Moving on to part B now. Okay. All right. We'll stick with A on the horizontal, C on the vertical. This one's a little bit trickier, right? We're going to have upward sloping indifference curves because we have a good and a bad, right? The question is, how is the slope changing? Is it going like this or is it going like this, right? Is it going to be getting steeper as we move to the right, or is it beginning to get flatter? All right, this is where I like thinking about how the marginal rate of substitution is changing. All right, so we know we're upward sloping because we have a good and a bad. So think about 2 points on the same upward sloping indifference curve. My marginal rate of substitution is going to be my margin utility of A over my margin utility of C, right? Looking back at my function, margin utility of A is going to be 1/2 A to the minus 1/2. Margin utility of C is going to be minus 1/2 C to the minus 1/2. So my minus signs are going to cancel out, my 1/2s are going to cancel out, and I can get rid of those negative exponents by flipping things, and that's going to be C to the 1/2 over A to the 1/2. Okay, why did I do that? Well, coming back down to these 2 points, here I've got smaller values of C and A, here I've got bigger values of C and A, right? What I can see though is that that doesn't really help me, okay? So C and A, if they're growing at the same rate, this thing is staying roughly the same. And so in this case, it's going to kind of depend on what your function was. You could potentially have your curve going like that. You could have it going like this. It really just depends on your function. No wrong answer there. You wouldn't get marked off for that, okay? All right, final function. We're going to our min function, okay? So here, once again, A on the horizontal, C on the vertical. We know that these min functions end up being these L-shaped sorts of indifference curves, right? Because you're constrained by whichever one you don't have enough of. And if I give you more of the thing you have too much of, it doesn't move you to a new indifference curve. It doesn't make you any happier, right? In this particular case, since we combine these things in a 1-to-1 ratio, those corners are going to be at that 1-to-1 ratio, right? So first one will be at 1 action, 1 comedy. Second one will be at 2 action, 2 comedies. Then at 3 actions, 3 comedies, and so on, right? And so when you're doing these questions on an exam, in cases where there's clear information given about particular ratios, like 2 action movies to 1 comedy, you're going to be able to come up with clear numerical answers on that. in cases where you're making arbitrary decisions about things like what these fractional exponents are, there's going to be lots of different correct answers for what this graph might look like, right? So when I'm grading a question like this, I'm just looking for, did you draw this as an upward sloping curve? Not did you draw it as getting flatter, getting steeper, right? When I'm looking at your utility function here, I'm looking, did you put fractional exponents to get that diminishing margin utility? Not did you pick 1/3, 1/4, 1/2. That's not important, right? All right, there we go.